So we'll start over here on, I'll just summarise quickly how you can solve these equations in your calculator, how you can reverse engineer it if you want to show that you factorised it when you didn't. So I think we're familiar with where we go in equation solver to polynomial. I saw you fellas doing it. And if you put it in, tell me the roots. This is what you get. You get -4 and 3 and you get positive half. Now, you absolutely have to, if they're the roots, thank you, you have x take -4 on 3, so that gives us the first root, and x take half, that gives us the second root. And then I'm putting this 6 out the front because the leading coefficient is 6. Alright? Now that's the way you absolutely have to do it, because if you just start trying to shove numbers up and stuff, sometimes it won't always work out. Occasionally you have a half root when the leading coefficient is not a 2. So you absolutely must do it like that. And then if you can simplify it, if you can distribute that 6, alright, I'm recognising, 6 has these factors 3 times 2, so I can put the 3 in this bracket, okay, 3x plus 4, and I can put the 2 in this bracket, 2x take 1. Okay, so that's how we've reversed engineered that. But this is what the polynomial factorises to, x take p, x take q, they're the roots, and then we deposited the 6 in there. Not that we need to do that part either. Okay, let's move on to 2c. Alright, so today we'll work through 2b and 2c. And we've got polynomial equality. Now this is taking us back to what we did in Year 11 methods in semester 1. So a couple of years ago for some of you, right, a year ago for the rest of you. So we've got, here's the polynomial. X plus 3 is a factor of this cubic. Now because x plus 3 is a factor, okay, x plus 3 is a factor, it means x plus 3 multiplied by some other polynomial will equal this. Square to take 9x plus 36. Now, if this is a linear factor, what do I need to multiply a linear by to get a cubic? Okay. It has to be a quadratic. This is x to the power of 1. I have to multiply it by some quadratic. And so that means I would put in here ax squared plus bx plus c. Now this a, we don't actually need this a because we know the leading coefficient here is 1, which means my value of a has to be 1 as well. X times ax squared has to be x to the power of 3. So if you want, you don't have to put that a up there. We can just leave it as x squared plus bx plus c. Okay, now we will expand this, and I'll stress, when we expand, remember we stagger them. So first I'm going to multiply the x through. This would give me x to the 3 plus bx squared plus cx. Okay, I'm just distributing the x. Then I will multiply the 3 through. So 3x squared, and I'm staggering it, right? I'm putting it underneath the x squared terms, so that we can collect those. Plus 3bx, and then plus 3c. Then when we collect them, we've got x to the 3 plus this collects b plus 3 times x squared. This will collect c plus 3b times x, and then we have plus 3c at the end. Now because these polynomials are equal, right, we said this linear times some quadratic, okay, is equal to this cubic. That means these coefficients have to be the same. Alright, so the coefficient of x squared here has to be the same as the coefficient of x squared over here. I have b plus 3 equals -4. Okay, this gives me b is -7. And I can look at the last one. I have 3c is equal to, that should be 36. 3c is equal to 36. So this gives me c is 12. Okay, so the constant term, 3c, equals 36. All right, everyone remember doing this skill? Excellent. Okay, so that means the quadratic that we have here is x squared take 7x plus 12. That's what this component is. Now we are asked to find all of the roots. Okay, it says, given this is a factor, okay, find all of the roots. So this polynomial then, it's x plus 3 times the quadratic factor. And if we want to find the roots, what do? We make it equal to 0. We then apply the null factor law. Here we'll get x is minus 3, or this quadratic component is 0. We need to factorize the quadratic component. Okay, two numbers that multiply together to give you positive 12. When you add them together, you get minus 7. That'll be x take 4 times x take 3. Minus 4 times minus 3. Positive 12. Minus 4 plus minus 3, negative 7. Equals 0. Apply the null factor law again. 3, 4, 4. So the roots of this cubic, okay, we found minus 3, positive 4, positive 3. 3 roots for the cubic equation. Excellent. Okay, let's have a go at the next one then. So this one says identify the values of A and B. Okay, identify the values of A and B and hence solve this equation. So in order to identify the values, we're going to have to perform that expansion. We have one quadratic multiplied by another. So I'm going to go x squared times x squared, x to the 4. X squared times bx will be bx to the 3. And do this carefully, because if you make a mistake, there's lots of places you could make. It's better to do it slowly and methodically rather than rush it and make a small error sometimes. Bx, x squared times minus 2 will be minus 2x squared. Okay, so all I've done so far is multiply the x squared term through. All right, then we'll move on to the ax. Ax times x squared, that gives me ax to the power of 3. Ax times bx gives me abx squared. And then ax times minus 2 gives me minus 2ax. Okay, so I've multiplied the x squared through, I've multiplied the ax through, now I'm ready to multiply the 2 through. So 2 times x squared gives me 2x squared. 2 times bx will give me plus 2bx. And 2 times minus 2 will give me minus 4. Okay, so we've staggered it. We've got 3 rows there. We're going to collect the like terms. We have x to the 4. We have a plus bx cubed. We have here minus 2 and then plus 2. Those parts are going to cancel. So we're left with ab x squared. We have 2b take 2a of x. When I combine those, I'm just putting, doesn't matter what order we put them in, the 2b take away 2a, lots of x. And then we have minus 4. So we've got to identify what the values of a and b are. Now I'm just missing a square there. That's a square. Plus 8 plus 8. Alright, so a plus b then. A plus b has to be equal to the coefficient of the x cubed term. What's the coefficient of the x cubed term?
0.
0. There is no x cubed term, which means its coefficient is 0. So thus we have a relationship between a and b. A is equal to negative b. Alright, so I've used that first piece of information. Now we can use either of these. This one's a product, so both of them will be equally the same. So it doesn't really matter which one we do. Let's go with this one then. If we have AB, A times B is equal to the x squared term. Now the x squared term is minus 4. Alright. And so now we've got to bring these two pieces of information together somehow to solve for A and for B. So what I might do is I might take the B value. Alright, I've got A is equal to minus B. So I'm going to substitute that in there for A. So what does that give me? It gives me minus b squared equals minus 4. So I have b squared is 4. I have b is plus or minus 2. Okay. Now, because we have, let's leave that there for now, and let's just investigate it a little bit further, because I think we've generated a number of too many solutions here. Let's investigate this circumstance. We have 2b take 2a, and that's equal to the coefficient of the x term, which is 8. 2b take 2a is equal to 8. All right, if we perform the substitution again, all right, I'm going to put minus b where the a is. Okay, so I'm performing that substitution that we identified earlier on. This gives me 4b is 8. This gives me b is 2. So look at this, we've discovered a discrepancy between these two pieces of information. This one says b equals 2. This one says b is plus or minus 2. So we have to go with the answer that satisfies both. What satisfies both? Positive 2. The negative does not exist over here. The negative value of b does not satisfy this solution, so the negative value of b is not a solution. Therefore, b has to be positive 2. And if b is positive 2, well then a is going to be negative 2. Okay, so that's the first part we've gone through. It has to satisfy all of them, okay? And so with one like this, it's worth investigating. Over here it will, and so forth. All right, so that's the first part done. We've found the values of a and b. Hence, solve the equation x to the 4 plus 8x equals 4x squared plus 4. So we're trying to figure out what's some link between these two. X to the 4 plus 8x. Might write that up here. We have x to the 4 plus 8x equals 4x squared plus 4. Okay. Can anyone see a link between this and this?
Just move everything over to the left-hand side on the bottom one, and then
Good. We've moved that over, and we've moved that term over. Yeah. So what's on this side at the moment?
Nothing.
Yep.
0.
0. Good. Okay. So the solutions to this then are the zeros. Okay. The solutions that satisfy this statement are going to be the zeros of this quartic. Now, this quartic can be expressed like that, or it can be expressed like this, x squared plus ax plus 2 times x squared plus bx, take 2. Okay, so it can be expressed like that. We've found the values of a and b, so we can sub them in. That would be minus 2, and that would be positive 2. And so if we want to know when this part equals 0, okay, the quartic we started with, we can just solve when this part equals 0. All right, so let's go ahead and do that. We'll do that over here. That's going to be the same solution for us. Now, one way we can check if we can factorize something, remember the quadratic formula, minus b plus or minus the square root of b squared take 4ac, all on top of 2a. You can factorize something if and only if b squared take 4ac. We call that the discriminant. B squared take 4ac is a square number. It has to be a positive square number. Alright, so what's a square number? 1, 4, 9, 16. Okay, 1 squared, 2 squared, 3 squared, 4 squared. You can only factorize if it's a square number. If we look at the discriminant of these, b squared, so that'd be 4, take away 4 times 1 times, b, let's write it out. So we've got x squared take 2x plus 2. So a corresponds with 1, b corresponds with minus 2, c corresponds with 2. b squared, take 4 times a times c. This will be positive 4, take away 8, we've got minus 4. Okay? Minus 4, so 4 is a square number, but because it's negative, it means it's not positive. So we can't find the roots via factorization. We cannot factorize them out. And the same will apply if we put in this one. B squared take 4ac. Let's do that one as well. So we'll have, in the next circumstance, a is 1, b is 2, c is minus 2. B squared take 4 times 1 times minus 2. 4 take minus 8, this gives us 12. This is a positive number, right? But it is not a square number, okay? 9 is 3 squared, 16 is 4 squared, 12 is not a square number of an integer. Okay, so that means we can't factorize either of these quadratic components, so we have to either use quadratic formula or put them in our calculator. We'll go through the first one using quadratic formula. So we saw that the discriminant of the first one was minus 4, so we can use that. Okay, we've already evaluated that for the first one, it was minus 4. So that means if I'm using quadratic formula for this quadratic here, we'll have minus b, so minus 2, plus or minus the square discriminant, all on top of 2a. Okay, now we can simplify that using complex numbers, right? The square root of minus 4 is the same as the square root of 4 times minus 1, which is the square root of 4i, right? Okay, so they're the two roots we get for the first quadratic component. Okay? 1 plus or minus I. And for the second one, all right, we saw the discriminant was 12. So we'll have minus 2 plus or minus the square root of 12 on top of 2. Okay, we can get them from here, we can get them from our calculator. Now I will take these further using surd operations. So if I'm going to simplify that, I'm going, what's a square number that's a factor of 12? And we would say 4 times 3, right? 4 times 3 is the same as root. And so we can split that into two parts. Root 4 times root 3. And what's the square root of 4 but 2? So we get minus 1 plus or minus root 3. So they're the roots of this component. And this one is the roots of this component. So our first quadratic had imaginary solutions. Our second quadratic had real solutions. Real, but they're irrational. Irrational because of the surd that had an infinite number of decimal places. Now, we did all of that for what purpose? We were trying to find the solutions of this equation. And remember, we said this equation is the same as this one being equal to 0, which is the same as this one being equal to 0. And so we went through and solved those two quadratics. Very good. Okay, last one. All right, we've got 2x to the 3 plus 15x squared. This is a beauty, by the way. 2x to the 3 plus 15x squared plus 24x plus k. It has 3 linear factors. 2 are identical. So if we have an identical linear factor, okay, 2 of them, that means it's a squared factor. If we have 3 identical linear factors, that means it's cubed, okay? So what this means, if we're going to find this, let's say we don't know what the factors are, but we do know one of them is identical to the other, so we'll square it, and then the other one will be some other number, we don't know what it is. Now we do know as well that the leading number out the front here is 2, isn't it? Okay, the leading number out the front here is 2. Now I'm going to deposit that 2 into this bracket. And we can do that because we haven't identified the value of b yet, we haven't defined it. So we can state this as x take a squared times 2x take b. We don't need to change the value of it. This is the polynomial we're trying to find. This is an identical linear factor. This is our other linear factor. Now, this cubic is going to be equal to this one. 2x to the 3 plus 15x squared plus 24x plus k. So we're going to perform the expansion and identify the values for a and b. and k. That's an unknown at the
Would you
end.
also put 2 coefficient in front of b?
No, I said we don't need to because we haven't defined the value of b. You can if you want to, but we'll just add an extra step to it. All we're trying to do is what's the number there, what's the number there. Yeah, so because we haven't defined the value of b, that's absolutely fine. So really, and even then, my reasoning here is just to demonstrate how I've arrived at this step. Why I've put the 2 in that one rather than that one, okay? All right, so let's perform the expansion. So let's do perfect square there first. We'll have x squared, take 2 lots of ax plus a squared. And we have 2x take b here. Now, whenever I'm multiplying a quadratic by a linear, I like to multiply the linear through. So I'm just going to chuck the linear on the left. It doesn't matter, it's just like a preference thing. And now I can see clearly 2x times x squared. So when I expand it, 2x times x squared, 2x to the power of 3. That's what we expect the leading term to be. Good. Then we have 2x times minus 2ax. Okay, that's going to be minus 4ax squared. So all I'm doing is multiplying the 2x through first, and then we're going to have here plus 2a squared x. Alright, multiply the 2x through, let's multiply the minus b through. So we'll have minus bx squared, we'll have plus 2abx, and we'll have take a squared b. Okay, we'll collect. And then we'll identify some relationships. Okay, so minus 4a take b, that's the x squared coefficient, has to equal positive 15. And then the other one here, 2a squared plus 2ab, the coefficient of x, has to equal 24. And then over here, minus a squared b is equal to k. Okay, we'll go through and solve. So first here, what we've got to bring them all together somehow. Now this adds a third variable, right? We've got a, b, and k. So it's like, well, let's do that way last. Let's find a and b first, and then we can worry about that one. So I've got to synthesize these two somehow. And I'm looking at this and I'm going, I've got a lovely lone b by itself there. B, just one lot of b. So I'm going to rearrange this to get b by itself. All right, so if I just shove the b on the other side, the 15 on this side, we'll have minus 4a take 15 equals b. I've got b by itself, and I can now plug it into here. Okay, I've isolated b. Let's solve by substitution. It's going to give me 2a squared plus 2a times minus 4a take 15. All right, so all I've done there, put that where the b is. Let's expand this and solve. We'll have 2a squared plus, excuse me, take 8a, take 30 equals 24. Excuse me, take 8a squared, take 30a. All right, collect like terms. We'll have minus 6a squared. Take 30a, take 24 is 0. Now this is a quadratic that we're trying to solve, right? And so we can straight from there you can use the slide rule, but all of a sudden you're doing, oh, minus 6 times minus 24, oof, stuff that. One thing we can do instead is 6 is common to all of these terms. In fact, minus 6 is common. Okay, I can factorize minus 6, or even I can divide every term by minus 6, right? So if I pull that minus 6 out the front, we have a squared plus 5a plus 6. Okay, now, because these quadratics are equal to 0, we can go through and divide by 6. We're trying to find the roots. So yeah, a squared plus 5a plus 6 is 0.
It's plus 4, isn't it?
Yeah.
Yeah, because 24 divided by 6.
Good, yeah, good. Good pick up. Okay, so I'm looking for two numbers that multiply together to give me 4 and 1. To give me 5, so 4 and 1, a plus 5, a plus 4, a plus 1. Apply the null factor law. Okay, so we've got two values for a. A is minus 4 and a is minus 1. Which means we're going to have two values for b. Okay, so if we have, if a is minus 1, alright, if a is minus 1, then I have minus 4. 4 take 15 equals b. I would have minus 11. Okay, so that's the first circumstance. If a is minus 1, b is 11. That's the first circumstance. And then we have if a is minus 4, now I have here minus 4 times minus 4, positive 16 take 15, where we have b is 1. So we've got two possibilities that satisfy this, right? And then we're asked, okay, well what about the value of k? Alright, remember we found a, we found b, we need that value of k. So k's got two possibilities as well. K depends on the values of a and b. So again, if a is minus 1 and b is minus 11, therefore k would be minus 1 squared take 11, which is minus 12. And if a is minus 4, b is positive 1, then minus 4 squared times 1, which should be negative 16. What did I do here? That's times, sorry guys, minus 1 times minus 11, that'll be positive 11. And then down here, that one's correct. Minus 4 squared, positive 16, negative 16, negative 16. Okay, so we've got two possible circumstances, right? Now these are enormous questions, right? So you think, what have we done? We've expanded it, we've identified the values of a, b, and k. What does the question ask us to do though? Find the roots. Okay, not much further. Remember up here, this is how it looked initially. We've found the values of a, we've found the values of b. But we still need to demonstrate both circumstances. So, in the case that a is minus 1, so we can just call that case 1. In case 1, a is minus 1 and b is minus 11. The polynomial then is x take a squared, so x take minus 1, so x plus 1 squared, times 2x take b, so 2x plus 11, and apply the null factor law here for these solutions, right? Okay, so that's the first circumstance. If those are the values of a and b, these are going to be the roots. And then in case 2, we're just applying the same algebra. It's a beautiful question because it gets us to practice so much algebra. In case 2, we saw a was minus 4, b was positive 1. That means the quadratic, the polynomial, is x plus 4 squared times 2x take 1. So we'll have minus 4 half. So look at that, we found the possible values of a and b, the possible values of k, and then in each circumstance what the roots are for the quadratic. So there's a number of polynomials that satisfy these conditions. That's what we're doing there. Well done. That was a ripper. That was a ripper to get through. So look, we've got about 5 minutes left, so it's up to you whether you want to spend some time on 2B or 2C. 2C will start very easily, but it will get into some more complex ones like we had at the end there. So it'll be my expectation by the next lesson that we're sort of up to 2D. All right, so we'll make a start on 2D next lesson. Thursday, so we've got a bit of tonight and tomorrow to have a bit of a crack at it. The questions on the front there. Any questions from you guys? Is everyone feeling pretty comfortable with the skills there? Yep, any questions to ask? No, Jeff, you're all right, are you?